Refraction by a lens. Figure shows the geometry of image formation by a double convex lens. The image formation can be seen in terms of two steps. First one is the first refracting surface forms the image I1 of the object O, as you can see in this diagram. The image I1 acts as a virtual object for the second surface that forms the image at capital I, as you can see in this diagram. We know that refraction from a spherical surface is given by n2 upon v minus n1 upon u is equals to n2 minus n1 upon capital R. Applying given equation to the first interface ABC, we get n1 upon OB plus n2 upon BI1 is equals to n2 minus n1 upon BC1. This one is equation number first. A similar procedure applied to the second interface ADC gives minus n2 upon di1 plus n1 upon di is equals to n2 minus n1 upon dc2. This one is equation number 2. For a thin lens, bi1 is equals to di1. Adding equation first and second, we get n1 upon OB plus n1 upon di is equals to n2 minus n1 into 1 upon bc1 plus 1 upon dc2, and this one is denoted by equation number 3. Suppose the object is at infinity, then OB tends to infinite and di will be equals to f. Equation 3 gives n1 upon f is equals to n2 minus n1 into 1 upon bc1 plus 1 upon dc2, and this one is equation number 4. The point where image of an object placed at infinity is formed is called the focus capital F of the lens, and the distance small f gives its focal length. A lens has two foci f and f dash on either side of it. By the sign convention, BC1 is equals to plus R1, DC2 is equals to minus R2. So equation 4 can be written as 1 upon f is equals to n21 minus 1 into 1 upon R1 minus 1 upon R2. We know that n21 is refractive index of medium 2 with respect to medium 1, can be written as n21 is equals to n2 upon n1. This is equation number 5. Equation 5 is known as lens maker formula. Note that the formula is true for a concave lens also. In that case, R1 is negative and R2 is positive. And therefore, focal length small f is negative. From equation 3rd and 4th, we get n1 upon OB plus n1 upon di is equals to n1 upon f. That is denoted by equation number 6. Again, in the thin lens, approximation B and D are both close to the optical center of the lens. According to the figure, applying the sign convention, BO is equals to minus U and DI is equals to plus V. We get 1 upon V minus 1 upon U is equals to 1 upon F. That is equation number 7. Equation 7 is the familiar thin lens formula. Though we derived it for a real image formed by a convex lens, the formula is valid for both convex as well as concave lenses and for both real and virtual images.